ladies and gentlemen. My name is Jay Ono from Team Korea, and I'd like to review the full discussion of problem Misty glass. So, let's start with the reporter's reinforcement. So they talk a lot about the theoretical things and made a lot of observatory experiments. But they need to provide justification for how other phenomena in light can be negligible, such as dispersion, backscattering, or refraction. For the experiment, also they needed the relationship between the parameters and the pattern has to be provided in the experiment. Now, for the opponents, they needed to explain more on the physical significance of this point. They talked about the random distribution of the water drop, and how it may lead to different conclusions for the report. And also they needed to talk more about the experimental setting to confirm the theory, not the observatory experiment. Now, let's move on to more important part, the clash, actual discussion, which was being present. So for the opponents, they pointed out that can we approximate the small drops as black disk? And this was a very crucial question because this question is about the fundamental reason why Misty glass pattern is present. And the reporter said the difference between the magnitude of drop size and wavelength is not significant, and this were needed improvement. So overall cost of this theoretical clash, not much physical conclusion was drawn due to lack of communication. Good points were addressed by opponents, but physical significance was not mentioned. Reporter needed more justification for her answers. Now for the experiment, there are also a few clashes. So the opponent asked, how does experimental result relate to the hypothesis of the report? And this was an important question. And the reporter answered that explained how the graph was obtained, and then this was needed proof. So let's move on to the general review of this discussion. Important part. So let's go back to the problem statement. The problem emphasized the water vapor, the condensation of water vapor, next the whiteness, and the color rings, and central fuzzy white zone. So the reporter needed to justify how they condensed the water droplets and actually see what differs when they control the water droplet for the Misty glass pattern. And I asked their question for both the opponent and the reporter that what can water drops do for the light passing through? So there could be a lot of answers: dispersion, reflection, scattering, refraction. So for the reporter and the opponent, they needed to justify why diffraction is so important. And before that, let's first look at the dispersion effect. So they had a discussion that dispersion due to the refraction can be neglected in small drops and cannot be neglected at the big drop. However, what I see is that the refraction is due to this angle, the surface curvature is very important. And for big drop, I bet that this small drop has bigger surface curvature, so actually dispersion will be greater at a small drop. So I think there's some errors, some misunderstanding in the concept of refraction. Okay, so that's the end of my presentation. Thank you very much.
Okay, concluding mark, 2 minutes from the report, please.
Thank you, dear opponent, dear viewer, for our discussion, for your question. But I want to say, first of all, about our experimental setup that we're not optimizing the methods of vapor. I said that we changed the method, but methods which are in our programs would give us the more clear picture about the effect of geometrical optics effect. As you know, the wave optic effect increase the geometrical, includes the geometrical optics effect. That's why we can say that we can study our phenomenon use only the wave optics, because it gave us the all explanation. And then that's all. Thank you.
Thank you. Okay, what remains now? Questions, of course, from the jury. 5 minutes. Yes, let's start.
Did you measure the spectrum of the LED?
We not build the spectrum of LED, but it's not solid. That's why we said that and every color in the spectrum are similar, and that's why we use this light source as we
Well, I have a question, but it relates to a slide. Can I please have slide 26?
26?
Well, perhaps. Would you like to ask your questions while they set the slide up? Would you like to ask your question?
Okay, to all three.
Sorry. Yeah, okay.
Do you think temperature can influence the result of the experiment?
What do you mean?
Do you think temperature?
Temperature?
You don't talk about that.
For example, temperature in our experiment will have influence on the drops. For example, when we have a high temperature of our air, our drops will vapor faster. That's why the time when we can observe our effect will be smaller. And when we have more.
Okay.
More.
Okay, thank you. Would you like to go back to your question, sir?
The question was, did you calibrate the response of your camera?
Yes, we calibrate our camera, and first of all, we can't make some photos because camera not absorb our phenomenon. And after that, we understand that our focal distance in camera must be like infinity. In other case, we can't make a photo of our camera.
The intensity response of the camera, did you calibrate that?
No, we don't calibrate.
Okay, can you go back to slide 26 now, then, please?
We use the same all the time. We don't change the parameters.
Okay. Slide 26, please. And I'd like to ask first the reporter, what do you think might be wrong with your diagram? From the report.
The brain, as I said, but we build a brain. It's not it's only one part because of course we have plain waveform and our code generate and use waveform, but we build it only for easier to understand about the difference in phase.
Okay, thank you. Does the opponent have any opinion on that diagram? Do you have an opinion of that diagram?
Not every ray will go in the same direction. If the ray will be here or here, the direction will change.
Okay, and
Okay.
review.
So that's just due to the refraction. So for this ray, it has to go straight because it has an angle of 90 degrees. And for this, it will make a dispersion.
Okay. Any other questions? Well, in the absence of questions, we need to decide on scores. If you'd like to sit down, please.